I'm Jacob Gadakian, a developer advocate at V-Systems. Prior to joining V-Systems, I worked as an entrepreneur, developer, and investor on various cryptocurrency projects and went full-time crypto in 2016. Today, it's my great pleasure to tell you about V-Systems, a new approach to distributed applications. V-Systems was dreamt up by our chief architect, Sonny King, as the ultimate application platform. Once you give it a deep look, it becomes apparent that VSys has taken great care to implement every feature in the simplest way possible. So this is kind of an introduction to how we've thought about design at VSys. In any complex system, including blockchain software, reducing the system to the bare minimum will enable reliability and performance. The V-Systems code base is less than 1/20th the size of Bitcoin's and was built using ScoreX, a simple and modular Scala blockchain framework. Our design philosophy influences every aspect of the V-Systems platform. For example, payments from supernodes to stakers aren't fixed. Payment terms for stakers are determined and promoted solely by the supernodes, who fully own the economic incentive design for stakers. The question for supernodes is, if you were getting 36 Visas per minute, how would you reward your supporters? It's fair to say that we take a minimalistic, even Spartan approach to software development. Using this simple design approach, we're going to be able to enable the rapid creation of application-specific sidechains for arbitrary application state sometime next year, with very little blockchain programming experience needed on the part of developers. The V-Systems blockchain platform lowers barriers to entry for developers and entrepreneurs by providing a clear, simple, Swagger-formatted REST API, providing flawless smart contract templates. Supernode Proof of Stake introduces a better staking model for enforcing blockchain security, one where every individual retains control of their stake and role. Stakers are able to stop staking at any time of their choosing without a waiting period. Supernodes design incentives that are designed to support their unique communities. Our platform is highly resistant to attack even by large stakeholders. The requirement to contend nodes ensures that changes to the supernode set are predictable. The minting average balance protects the network against floods of new stake that could enable rapid contends by hostile supernodes. So basically, the entire platform is really designed around making it as easy as possible for developers to start building blockchain applications. Supernode Proof of Stake is a consensus mechanism designed by Sonny King, the creator of Proof of Stake. Supernode Proof of Stake is an efficient distributed consensus algorithm with high resistance to 51% attacks. It's performance-oriented with high scalability and transaction throughput. It has a stable minting economy and allows users to self-govern. There are no barriers to participation in minting through coin leasing. So basically how this works is that users lease out their right to mint coins to supernodes, and they are rewarded by supernodes in a manner of that supernode's design. In the diagram here, we see kind of an 80-20 split where the supernode is taking about 20% and the users are receiving about 80% of the minting reward. On the V-Systems blockchain, all users have a right to mint, and they also have the right to migrate freely between supernodes. Now I'd like to tell you a little bit about our Euclid smart contracts. Concerning smart contracts, we've also chosen to take a minimalist approach. Smart contract execution always costs 0.3 Visas, and you'll find that our contracts entirely lack logic. Instead, our smart contracts are designed to be chained to one another. Veces smart contracts are always the same and require zero blockchain development work. Like no-code software systems, our smart contracts are built with entrepreneurs in mind. Veces users can rapidly prototype applications without writing a single line of code or doing an expensive security audit. We are taking that design philosophy and applying it to every aspect of the Veces platform. Instead of giving users the ability to do nearly anything with Veces by implementing Turing completeness, we cover 95% of the most common blockchain applications extremely well, and users don't need to write code for those. Our contracts compose easily due to their simplicity as well. And kind of what you can see here on the slide, so we feature 4-second block times. It's very easy to, for example, make a token from your phone, and our design pattern increases security by ensuring that every contract has been completely audited and it's just ready to go. You can instantiate it as many times as you'd like. Staking 2.0 is a token distribution mechanism for Veces ecosystem projects that allows ecosystem projects to award a portion of their token supply to supernode stakers. It's used to promote community growth and allows stakers to participate in the development of V-Systems powered projects. It also facilitates the development of the overall ecosystem, kind of making a literal connection between ecosystem projects and the security provided by the Veces blockchain. And now I'd like to kind of jump into a real world use case of staking 2.0. We have an ecosystem project called Tachyon, which is a distributed node network and VPN service provider. And Tachyon has 1 billion tokens, and they wanted to distribute 100 million of them to Veces stakers over a period of 2 years. What this does is it created a clear connection between the success and security of the V-Systems blockchain, where Tachyon settles its transactions, and the success of ecosystem projects like Tachyon. With staking 2.0, we've automated and formalized the connection between staking Veces and the expansion of our ecosystem. Veces ecosystem projects all have the option of distributing some of their tokens to people who have earned them by staking Veces. Staking 2.0 is not an airdrop. People do not value things that are free, and that's my thinking on why most airdrops have failed. Giving the token away sets the price to zero from the very start. Staking 2.0 ensures that everyone who is putting aside the time and energy to secure the network by staking on Veces supernodes earns a reward in some ecosystem projects who choose to implement staking 2.0. And now I'd like to tell you a little bit about Tachyon itself. So Tachyon is basically our flagship product right now. And it launched its VPN app in March 2020. We've now gotten 350,000 users. V-Systems works closely with Tachyon to develop smart contract features suited to their desired functionality and drive popularity of its IPX token. And this kind of gives me an opportunity to talk about how we want to partner with projects. So in Tachyon, you can see our close partnership model playing out. Our portal payment channels on V-Systems were actually designed specifically around Tachyon's need for machine speed payments. And this resulted in a unique feature for the V-Systems platform, as well as an elegant solution to real-time payments. Portal allows for payments as frequently as 1 every 10 milliseconds, or even faster if you had a network connection fast enough. Portal does not need a secondary peer-to-peer network like Lightning and most other payment channel solutions. A REST API is enough. We're going to repeat this collaborative approach with other ecosystem projects. Portal's origin story is The Tachyon team, they wrote some Solidity. It's actually still on the GitHub today, and realized that it wouldn't be fast enough for their needs. Tachyon consulted with vSystems, and together we designed an appropriate solution that is simultaneously an excellent use of smart contracts and an industry first in terms of speed and simplicity for payment channels. If there's a blockchain feature that you need for your project, or you're not really sure how to implement something that you need to do what you'd like to do, please do reach out to us. We listen. So now let's get into the Veces Coin. Veces Coin is the native currency of the vSystems blockchain platform, and it is used to pay transaction fees, access applications built on vSystems, and for platform governance via the SPOS minting scheme. In November 2018, 5,142,858,000 Veces coins were generated in our Genesis block. 283,824,000 Veces are produced annually by the supernodes. Veces currently has an annual inflation rate of about 5%. Inflation declines with time because the rate at which new Veces is produced is always 283,824,000 Veces per year. On the Veces platform, all transaction fees are burned. Send transactions cost 0.1 Veces, and smart contract executions cost 0.3 Veces. Our coin offers our blockchain community a stable and easily understood economic environment and a steadily declining annual inflation rate. So next, I'd like to talk to you about a set of smart contracts that we're releasing in our upcoming Fermat software release. These 3 smart contracts all follow our minimal smart contract design. They are endlessly repeatable and super reliable and can be implemented with no code whatsoever. The lock contract allows users to lock up a token or Veces until a certain clock time or block height is reached. This allows for projects to more easily implement staking features with their tokens. Non-fungible tokens. So our non-fungible tokens are probably about as simple as they get. They're designed.
I just want to cut in quickly and remind you we have 5 minutes for Q&A.
Oh, wonderful.
Left at the end. So I'll let you finish the slides a little bit, but I want to leave some time for the questions from the audience.
Absolutely. Very, very simple non-fungible tokens that allow for many, many different use cases. And then finally, portal payment channels, which allow for incredibly high speed, trustless payments, with the only assumption being that you can see that the recipient's wallet can monitor the state of a smart contract on the chain. Lastly, we're doing a lot of ecosystem development, including work with centralized and decentralized exchanges. We're collaborating actively with POS communities, and we're looking to work with wallet and staking providers and build partnerships with tech and finance companies. And with that, I am going to yield the floor to questions. Thank you so much.
All right. Thanks, Jacob. So first question, so I guess, could you elaborate a little bit on the idea of no code or minimal code smart contracts? Like how does that work?
Sure. So basically each contract is a template that's actually stored, in the chain code itself. And when you want to do something with it, what you're really doing is you're instantiating it.
Okay. So is it kind of like, so they kind of like built into the vSystems protocol already, and you're just kind of like calling it?
Yes, that's exactly.
Okay.
Yep.
Got you. So what would be an example of composing the no-code contracts?
Okay, an example of composing the no-code contracts could be something like locking up funds until a certain time, having an external application monitor that, and then calling a portal, for example. Another example of this could be off-chain. So, just for example, you could have say you wanted to implement like a peg, right? You could have a Veces token on the Veces chain, and you could actually migrate that to another one by monitoring the state of the token on the chain. Another one would be basically like event triggers. So you see that X, Y, and Z has happened, and then you program something else to happen on chain as a result of that event.
Gotcha. And I think just one final question before we run up on time here. So I guess like Sunny King is kind of the inventor of proof of stake.
Yeah.
And there's a lot of projects that are either have launched in our proof of stake or are migrating over to a proof of stake network. And then also you guys as well are continuing to iterate on your own proof of stake mechanism. So I'm curious to hear what are some lessons that you guys have learned about proof of stake, and what are some of the challenges you're seeing for your project personally?
Sure. So I guess I'm going to kind of launch into some Sunny King thinking on economic design. When I was talking to him about a similar topic, what he gravitated to was that what's most important isn't actually how the chain comes to consensus. What's most important is that the chain has an economic design that is free of shocks. He mentioned, for example, the Bitcoin halving as a shock to the Bitcoin ecosystem, and said, well, you can have a declining supply, but maybe it should be a gradient. That's part of the thinking behind, for example, why Veces has a fixed rate of inflation, is to just sort of keep things very steady. So that was part of the thinking behind that proof of stake design. And then, all right, if you want a little known like tech detail, it's actually really, really cool if you go into our API and query it once every 4 seconds. We have a thing called the MAB, minting average balance, and no one else has this. And what it does, it ensures that stake comes online slowly. So over the period of about 4 days, a user's stake comes onto a chosen supernode. And that's another piece of design that's basically there to ensure that there are no big shocks to the ecosystem by, for example, volatility in the set of supernodes.
Gotcha. All right. Well, I think actually we ran a little bit over, but where can everyone learn more about yourself and then V Systems?
Sure. So I'm at Gatakian on Twitter. That's really the best place to go. I tweet quite a bit. And if they want to learn about Veces, they can go to our website. The URL is actually v.systems.
All right. Thank you, Jacob.
Hey, thank you.